This video is on adding and subtracting using scientific notation. Adding and subtracting using scientific notation. All right, our first example is 1.34 times 10 to the 8th plus 4.5 times 10 to the 6th. If you remember from our last video, the 1.34 is considered the coefficient, the 10 is considered the base, and the 8 is the exponent. Okay? So right now, thinking all the way back to I think Unit 2, we have unlike terms. We cannot combine unlike terms, and these terms are unlike because one base is raised to the 8th power and one base is raised to the 6th power. So what we do when we add and subtract using scientific notation is we manipulate one of the numbers so that we can have exponents with our bases that are the same. And it doesn't matter which of the two you manipulate, as long as you make sure that when you get your final answer, it's in proper scientific notation. Now, it is wise to always pick the larger exponent and make both of your bases raised to that higher exponent, which means you're going to want to take the coefficient that is with the base to the smaller exponent and manipulate it so that it's the larger exponent. But for this first example, I'm going to show you both so that you can see it doesn't matter which one you choose. So, I'm going to split my screen, and on the left, I am going to make it to where both exponents are 6. Okay? So, right now, this is the one that I would need to manipulate because this one has a 6 as the exponent, this one has an 8. So I have 1.34 times 10 to the 8th. Okay? If I want it to be 6, that means I need to subtract 2. Alright? If I want to subtract 2, that means that I need to move my decimal place to the right 2 times. That's going to give me 134 times 10 to the 6th. Now I'm ready to combine like terms, 4.5 times 10 to the 6th. So we're adding with decimals. We need to follow our rules for adding with decimals, which says that you line up your decimal places. So I have 134 plus 4.5. So my decimals are lined up. And I have 138.5. Okay, so 138.5 times 10 to the 6th. Now notice this is not in proper scientific notation, because for proper scientific notation, your coefficient needs to be smaller than 10, but greater than 1. So right now it's much, much larger than 10, which means I need to move my decimal place 2 places to the left. Moving it left means I add 2, and I get 1.385 times 10 to the 8th. Okay? Let's look at it by saying, well, let's pick the higher exponent. So now I want both of my exponents to be 8, which means this is the term that I have to manipulate. So I have 4.5 times 10 to the 6th, okay? I want it to be 10 to the 8th, which means I add 2, which means I need to move my decimal 2 places to the left. So that's going to give me 0.045 times 10 to the 8th. Now I'm ready to combine my like terms. My other term was 1.34 times 10 to the 8th. Again, we need to line up our decimals. We have 1.34 plus 0.045. So this is 5, 8, 3. Our decimals stay in line, and 1. So we have 1.385 times 10 to the 8th. Notice these two answers are the same. So it doesn't matter if you go with the smaller exponent or the larger exponent, as long as when you get your final answer, everything is in its correct place. This is why it's typically a good idea to use the higher exponent. So for the next examples, I will pick the higher exponent in each example, therefore manipulating the number that has the smaller exponent to bring it up to the higher exponent. All right, our next example is 4.801 times 10 to the third minus 2.2 times 10 to the seventh. Okay? So I've identified my higher exponent of 7, which means that I want this number to be 7. Okay? That means that I need to move my decimal to the left, and I've already done all my work on a separate sheet of paper. So this is the one that I want to manipulate. Okay? I'm going to move it, 7 minus 3 is 4, which means I need to move it 4 places. So 1, 2, 3, 4. Fill in my divots with zeros. So my new number is 0.000481 times 10 to the 7th minus 2.2 times 10 to the 7th. Okay? Now if we remember our rules for adding and subtracting decimals, if we are looking at A minus B, okay, so this is my A, this is my B. If the B is a larger number than the A, which it is, 2.2 is larger than 0.000401, then we do B minus A and make it negative, okay? So again, we want to line up the decimals, so we have 2.2 minus and 0.004801. Remember, we fill in with zeros, and then we do our math. Okay, so I need to come all the way over here and borrow, which makes us 9, 9, 9, 9, 9, and 10. And then we have 9, 9, 1, 5, 9, 9, 1, 2. Okay? So now, I have 2, and sorry, it needs to be negative. So negative 2.1995199 times 10 to the 7th power. Okay? It is in scientific notation. My coefficient, it is, the coefficient 2 is there. Okay? All right. Next problem. I need to think more on this one, but anyway. All right, next problem is 2.456 times 10 to the 5th plus 6.0034 times 10 to the 8th. My higher exponent is the 8, so I want to manipulate this number so that I have it to the 8th power. And so that means that I want to move it over 3 places, 1, 2, 3. My new number is 0.002456 times 10 to the 8th plus 6.0034 times 10 to the 8th. Okay? Now I have like terms, I'm going to combine them. If it is okay with you, I'm not going to show the math of these two numbers. Just remember you have to line up your decimals and then add everything. And so these two numbers added together are 6.005856 times 10 to the 8th. And it is in scientific notation, so we do not need to do anything further. Alright, let's look at one that has negative exponents. Again, I'm going to use the higher, which is negative 17, which means I need to manipulate this one so that I have a negative 17. Okay? So that means that I want to add 1. I want to add 1, which means I need to move my decimal place over to the left 1 time. So then I have 9.7821